Hello, my dear students, and the rest of the learners. Welcome to part 19 of a 95-part series of tutorials in object-oriented programming in C++ by the title Data Types Conversions. My name is MemJM, or you can simply call me MLSwap. Typecasting is making a variable of one type, such as int, act like another type, for example, car, for one single operation. To typecast something simply means that you put the type of a variable that you want the actual variable to act as inside parentheses in front of the actual variable. For example, if you want to typecast R to type character, you enclose car in parentheses followed by the value of what you want to typecast, for example, R, which will in this case make A function as type car. One use of typecasting is when you want to use the ASCII characters. For example, if you want to create your own chart of all the 256 ASCII characters, you will need to use a typecast to allow you to print out the integer as its character equivalent. In C++, you can typecast, for example, integer 65 to be of type char by enclosing 65 in a pair of parentheses preceded by char. That is char. Then we have opening parentheses, 65, closing parentheses, and a semicolon. This is more like a function call than a cast, as the type to be cast to is like the name of the function, and the value to be cast is like the argument, the function. In this case, I mean that ordinarily, when you are making use of functions and you want to pass a parameter to the function, then you enclose the parameter or the argument in a pair of parentheses. And therefore, in this case, car in this word or car in this case will be almost like a function into which you are passing an argument to, that is 65. You typecast when you want to force the correct type of mathematical operation to take place. Standard conversions affect fundamental data types and allow conversions such as the conversions between numerical types, such as short to int, int to float, double to int, amongst others, Boolean type, and some pointer conversions. Some of these conversions may imply a loss of precision, which the compiler can signal with a warning. This can be avoided with an explicit conversion. For example, the value of, for example, a short can be promoted to int by assigning it as follows. You can assign, for example, 2000 into A, which is of type short. And then if you declare a new variable, which is of type integer, for example, B, then we can easily assign the value of A to B, because this time round, both A and B will be of the same type, which is type integer. Implicit conversions also include constructor or operator conversions, which affect the classes that include specific constructors or operator functions to perform conversions. For example, if you have a class called max, which is empty, in other words, if there's nothing inside, which you can write as follows, then we can also have, for example, another class called results. And inside it, we have a member who is of type public or who has a public scope by the name results. This is a method, and this method called results is what we are calling a constructor function. Why? Because as you can see, the name of this function, results, is similar to the name of the class in which results function is a member. So this function called results, or this member called results, is having a parameter of type max, which is a of type max, and we don't have any statements or sequence of instructions being executed inside this function called results. And then we can have a, which is of type max. And from there, we can assign a to b, which is of type results. Here, an implicit conversion happened between objects of class max and the class results. Why? Because results has a constructor that takes an object of class called max as parameter, just as you have seen, just as you can see here. Therefore, implicit conversions from max to results are allowed. Let's now look at what we call explicit conversion, that is explicit type checking. The two types of explicit type conversions are as follows. We have, for example, 2000 being assigned to a variable of type short. That is, 2000 is being assigned to variable called A, which is of type short. And then once we declare a variable called B of type integer, then we can assign A to B, but we have to first of all convert A, which is of type short, to become integer using a statement. As you can see, that is enclosing int into a pair of parentheses followed by A. And then that conversion, which is now is of type integer, is then being assigned to B, which in this case, B is a variable of type integer. So we call this C-like cast notation. We can also make use of functional notation, as you can see, by enclosing what we want to convert. That is A, which of course in this case is of type short, to the type we are typecasting it to, that is integer. And then the results that we get, we assign them to the memory location of the variable called B. In order to control indiscriminate typecasting of classes and the pointers that may generate errors, we have four specific typecasting operators. These are dynamic cast, reinterpret cast, static cast, and const cast. Their format is to follow the new type enclosed between angle brackets and immediately after the expression to be converted between parentheses as follows. The syntax is, for example, dynamic cast, new type, and then we enclose the expression in a pair of parentheses. For the interpret cast, we just replace the one dynamic cast with the interpret cast, and the syntax remains. We also do the same for static cast and the const cast. So the format is the type of cast, for example, dynamic cast, followed by the new type, or the new type that we want our variable to get, and the expression. How do we do each of them, or how do we work with each of them? Let's begin by looking at dynamic cast. Dynamic cast can be used only with pointers and references to objects. Its purpose is to ensure that the result of the type conversion is a valid complete object of the requested class. For example, we have a class called CBase, which is empty. We also have a class, we can have a class called CBase or C-derived. And then we have the CBase class being under the scope of the C derived. So we can write it as follows. And then we have a B, which is of class C base. And we have a pointer to the class called B. That is, we have a pointer called P, which is for the class C base. We also have, or we can have, D being of class C derived. We can also have a pointer on D, which is for the class, or pointer of the class called C derived, and we can write for code as follows. Remember what the symbol means. The asterisk in this case is called the reference operator. From there, then, we can have derived class to C or to base coded as follows. So we have the reference operator D, or we have the memory address for D. And then we have, of course, as you can see, we have pointer to C base. And the typecast for the dynamic cast for C base is then assigned. Or once C base has been typecasted, once it has been typecasted, the results are assigned to PD. When a class is polymorphic, dynamic cast performs a special checking during runtime to ensure that the expression yields a valid complete object of the requested class. Let's now look at what we call the static cast. Static cast is used to perform conversions between pointers to related classes, not only from the derived class to its base, but also from a base class to its derived class. This ensures that at least the classes are compatible if the proper object is converted, but no safety check is performed during runtime to check if the object being converted is in fact a full object of the destination type. Therefore, it is up to the programmer to ensure that the conversion is safe. On the other hand, the overhead of the type safety checks of dynamic cast is avoided. Like, for example, if we have a class called CBase, which is empty, coded as follows, then we can have CBase being or having a scope, a public scope, but being, or that means, let me rephrase this statement. If we have, for example, a class called CBase, which is empty, then we can assign its scope to the derived class. And this CBase class is accessible because it has what we call a global scope, and we can code it as follows. From there, then, we can create a new CBase class, and we can assign it. We can assign that class to CBase. But how do we really interpret that or explain that? We can have new, or we can have the CBase class, which is new, being assigned to the memory location pointed to by the CBase class, or by the pointer of the CBase class called A. And from there, we can assign, or we can convert the scene derived statically, or using what we call the static cast, and the results we get, we assign them to the memory location called B, or the memory location being pointed to by the pointer called B, which is of the class derived. This will be valid, although B would point to an incomplete object of the class and could lead to runtime errors if dereferenced. Static cast can also be used to perform any other non-pointer conversion that could also be performed implicitly Like for example, standard conversion between fundamental types. Like for example, we can have this value 3.14159.265 being assigned to a variable called d, which is of type double. And then we can typecast d to integer. And then from there, once we convert the double to type integer, we can then typecast or statically cast the results that we get and assign them to the memory location called I, which is of type integer. Let's now look at what we call the interpret cast. The interpret cast converts any pointer type to any other type, even of unrelated classes. The operation result is a simple binary copy of the value from one pointer to the other. All pointer conversions are allowed. Neither the content pointed nor the pointer type itself is checked. It can also cast the pointers to or from integer types. The format in which this integer value represents a pointer is platform specific. The only guarantee is that a pointer cast to an integer type large enough to fully contain it is granted to be able to be cast back to a valid pointer. The conversions that can be performed by the interpret cast, but not by static cast, have no specific uses in C++ and are low-level operations whose interpretation results in code which is generally system-specific and thus non-reportable. For example, if we have a class called A, which is empty, and we also define a class called B that is empty, then we can have a new class called A, which can then be assigned to A, which is a pointer to class A. In addition to that, we can then proceed and reinterpret cast A to B, and then we assign the results B, which is a pointer class called B. This is a valid C++ code, although it does not make much sense, since now we have a pointer that points to an object of an incompatible class, and thus referencing it is unsafe. Let's now look at what we call the const cast. This type of casting manipulates the constantness of an object either to be cast to or to be removed. For example, in order to pass a const argument to a function that expects a non-constant parameter, we can do it as follows. So this is a sample program which illustrates const cast. We have this statement, the preprocessor directive for our string that we are used to, and then using namespace standard. And then from there, we can have print. That is a function. We can have a function called print, which is of type void, and it is receiving a variable or a parameter called str, which is a pointer to car. Then inside this function, we can have the following operations. We are displaying the results or the value found in the parameter called str. From there, we have int main, which is the main function that is expected to be, or to, the main function in every C++ program, which controls the flow of the program. And then we can have a statement like you can see, which is a sequence or a series of characters that can then be assigned to the memory location called C, which of course is a pointer to car, and that is const car C. My dear students and the rest of the learners, it's my hope that you remember what this type of statement means. Remember what is enclosed in double quotes. The opening and the closing double quotes is just a stream of characters or array of car, which is then being assigned to C, or memory location code C. And it is being done as a constant. So the value which is being assigned to C will not be changing during program execution. And then from there, we can be able to print the results or to print the value of C using a statement as follows. It's my hope that you can see how we are making use of the typecast, that is the const cast. Then we have return 0, which indicates the end of execution of the instructions within main, telling the compiler or telling the processor to take back control the operating system. And then we end the main program or the main function. So let's see how this program would behave or behaves if we code it in C++ program. So what we are going to do is we are simply going to copy this program, paste it in an editor for C++, compile it and execute it, and then we are going to see the results that we are going to get. So if, for example, I was to copy this program that you can see on the screen, it is expected that as a student, you can directly copy this program as it is, or you code it in your editor, for example, C++, and then from there, you can compile it. I'm therefore going to copy this program as follows, and then from there, I'm going to start C++, a programming language, as follows. As usual, we are going to launch Visual C++ 2010, and then we click on File menu, point to New, and click on New Project. Once we click on New Project, just as you have been doing before, you can click on Win32 and then Win32 console application, and then you can type the name of your program or project and the name as follows. In this case, I'm going to call it const cast. The location will remain, also the solution will remain, and therefore I'm going to click on OK. Once that is done, then you can be able to proceed as follows. The location will be determined by you based on where you want to store your program. So the name of this program that we are going to code, just as you have seen from the presentation, is const cast. If you find that the name is being resistant by your program during saving, you are free to change its name. What is more important is for you to note that the name that you make use of, that is the name that you use for your file, should always be self-explanatory. In other words, when somebody reads the name of that program or the name of that file, he or she can be able to identify what that program is doing. Like in this case, after typing const cast, and then when I click on OK, you can see I'm being told that the program won't be created because another project already exists. So let me call it const cast 1. And then I'll click OK. Then from there, I'm going to click on Next, click on Empty Project, and click on Finish. Remember, Just as I have said in the previous presentations, the process is determined by the version of C++ program that you are using. So in some cases, you may not follow this advanced process because there are various processes or procedures that can be followed for various languages, or various versions of C++. And then under file name, because we are coding a program, we are creating a source code. I'm going to click on code, then C++ file. Then the name of my program will be cast1. And then I'll click on and. From here, I can just right click and click on paste. Remember, you can always write this program in a Word or in an editor program, for example, in word processor or even in Notepad. And then once you have coded your program, you can be able to copy that program and paste it directly into an editor or C++ like I have done. However, you can also directly do the coding, or you can write the program in your exercise book, dry run it in your exercise book, and then you can be able, or you can proceed and decode it in your C++ program as follows. Then you need to save it. Then for Visual Studio C++ 2010, to execute this program or compile this program, we need to click on Build and then click on Build Solution. In case our program has no errors, we are going to see success. As you can see here, our build has been successful. So we can then proceed and execute this program by clicking on debug, and then we click on start without debugging. My dear students and the rest of the learners, you can see the output from my program. That is, this is the output from this program that we have, or that I've already explained. So my program is simply displaying the message, MLSWAP ICT Live Schools Glorious Ministry YouTube channels. So that's the output from our program. We can then press any key to continue. Let's now look at what we call the type ID. What is type ID? Type ID allows you to be able to check the type of an expression that you have. And the syntax is type ID, and then we enclose the expression in a pair of parentheses. This operator returns a reference to a constant object of type info that is defined in the standard header file type info. This returned value can be compared with another one using operators, then double equal to, or what we call the assignment operator. The assignment is this. Let me ask you, my dear students and the rest of the learners, is this symbol an assignment operator, or it is an equal sign operator? This is an equation operator, or equal sign operator, which checks if a value is equal to another one, and not equal to. So we can easily call the first operator equal to operator, and the other one is not equal to operator, or can serve to obtain a null-terminated character sequence representing the data type or a class name by using its name or using the name of the function member. This is an example of a program, type ID, or that implements type ID. We, of course, have the outstream preprocessor directive, and then we need now to include the type info preprocessor directive that contains the definition and the details that are supposed to be applied in our program, or that our program or compiler needs to be aware of in as far as the type info is concerned. Then we have using namespace standard, we have our main function there, and then we are defining or we are declaring two values here, or two memory locations, B and A, whereby B is a variable while A is a pointer. And both of them are of type integer. And then we can assign 0 to memory location called A. And then we can also assign 0 to memory location called B. From there, we can have a statement as follows. For example, if type ID A is not equal to type ID B, then write out the information that A and B are of different types. Then drop one line. In addition, proceed and display the message that A is, then display the character or the results of type ID A dot name. Simply, this statement will be able to write out what is under the member called name. And then we have C out. B is then the results of type ID B dot name. And then we end the if section. Then we turn back or take back the control, the operating system, and end the program. So let's see how this can be done in C++. So what we are going to do is we are just going to copy this program just as it is, and then we paste it in C++ editor and compile it. So let's proceed. So I'm going to close this program that I decoded, and then start a new project. This win32 win32b, and then what is the name of our program? The name of our program is type ID. So the project will be by the name type ID. And then I'll click OK. If you are told that another one exists, then I can write it as, or I can type it as type ID 1. Then click OK. And then proceed. Remember, the most important information that we need to know is how to start editor in your program, in your C++ program. So once you have done that, because I'm making use of Visual Studio 2010, C++ 2010, I'll click on C++ file there. Then I'm going to write again, then give the name of my program as type ID 1, and then click on Add. Then I can copy my program. This is my program, which I expect you to be able to code in your exercise book or even in another editor. For example, word processor. Once you have gone through your program, you can then paste it in a C++ editor, as you can see. I'm then going to save my program. To compile this program in Visual Studio 2010, C++ 2010, I'll click on Build, then click on Build Solution. This is how we compile it in C++ 2010. Once it's successful, as you can see, it means that my program has no errors. I can then proceed and execute it by clicking on Start without debugging. Let's see what we are going to get. So these are the results. This is the output that we are going to get from our program once we run it. As you can see, so this is our output. This is the output for this program. From there, I'm going to click or press any key to continue. Once you press any key to continue, you can see you'll be taken back to your program. As you have seen, when you run it, that's what you're going to get. You are being told that the first statement here, C out, is displaying A and B are of different types. Then A is a pointer of type int. B is of type integer. Simply that the information that this program is meant to display. Then I'll press indicate continue. Let's now proceed. When type ID is applied to classes, type ID uses the RTPI to keep track of the type of dynamic objects. When type ID is applied to an expression whose type is a polymorphic class, the result is the type of the most desired complete object. An example of such a program is file name type ID polymorphic. Then we have reprocessor directive outstream, reprocessor directive type info, reprocessor directive exception. Then we have using the namespace std, and we have a class called cbase, which has a member called f, who is of visual void type, and it is empty. Then we have another class called cderived, and public or cbase is now under the scope of cderived. In other words, cbase, you can say, is a class under cderived, and its scope is public. We are going to learn more about the derived and the base classes in subsequent series of tutorials in this series. This class called cbase, or this class called cbase, is also empty. Does not have any sequence of statements to be executed. Then we have main function, and we have the function try, and we have a cbase, which is new, or a new class called cbase being declared, and it's being assigned, or the results are being assigned to A, which is a pointer to cbase class. We also have new cderived, or we are creating a new memory location for a class called cderived, and then we are assigning what we get to B, which is a pointer of type cbase class. Then we have cout, or we display the following, that A is, we display the results of type ID A dot name, and we drop, or we write out one blank line. We also display the next statement as B is, we get the results of type ID B dot name. We also then display the next statement that pointer A is. So we pick the value in the memory location called A.name. And then, so the results of type ID A.name are what we display, followed by a new line, or we drop down the pointer or character to the next line, new line operator to the next line. And then we also display that pointer B is, we display the results generated by the expression type ID, opening braces, opening parentheses, pointer to B, closing parentheses, dot name. And then we add that function. And then we have this other function we call it catch. And we have the expression exception E, or the address of E. Then we write out. Remember, this is a function. So what we have enclosed inside the pair of parentheses, exception E, that is, it is receiving the address of E. And then we are writing out exception. Then we pick out, or without the value that is generated from E dot what function. And then we return the control back to the operating system. My dear students and the rest of the learners, we are going to learn more about the try and the catch functions later in the series, or in the sequence of this series of tutorials or presentations. From there, we take back the control of the operating system, and we end the program. When type ID is applied to objects like pointer to A and pointer to B, type ID zeroes their dynamic type, that is, the type of their most derived complete object. If the type ID or type ID evaluates in a pointer preceded by the reference operator, and this pointer has null value, type ID throws a valid type ID exception. My dear students and the rest of the learners, before we continue, let's see how this program is going to behave when we code it in our C++ program. So let's copy this program just as it is, and then we paste it in our C++ editor, and then we see the results that are going to be generated from it, or we see its output. So how do we proceed? We are going to proceed by launching C++ program, and then we copy this program into our editor and we compile it. So let's proceed. So to code this program in our C++ program, we are going to proceed as follows. I'm going to launch my C++ program and then click on File, New, Project, which is Win32 console application. And then the name of my program is going to be type ID polymorphic, and therefore I'm going to type the name type ID polymorphic. Remember, you are always free to use any other name. What is important is to ensure that you make use of names that are meaningful, whose meaning you can be able to tell even later. I'll right-click on source files, click on new item, click on code, C++ file, and then the name of my program will be type ID, then polymorphic, and I click on add. I'll then select my program. Remember, you are always free to write or to make or to code this program in an editor, like it is for my case, and then you paste it directly to your editor. This is usually advisable so that you don't waste a lot of time writing one by one in your editor screen in C++ program. However, there's nothing wrong even if you start the editor and you code each of the statements directly on your editor. Once you are through with coding your program as I've done, remember to save your file. Then to compile, I'll click on build and then build solution. If there will be any errors, they are going to be displayed. But if no error, you are going to receive a successful message like it is in my case here. So this means that my program has no errors. I can then proceed and execute it by clicking on debug, then start without debugging. What kind of results is our program going to give us? These are the results. So the first cout is displaying that A is class CBase pointer to CBase class, while B is a pointer to the CBase class, while pointer A belongs to class CBase and pointer B belongs to class C-derived. So basically, this program is intended to show you how we make use of type ID and how we make use, or we can refer to the classes like CBase and C-derived classes. You can then press any key to continue. So that's what type ID is all about. Remember, when type ID is applied to objects like pointer to A and pointer to B, type ID uses the dynamic type. That is, the type of the most derived complete object, as you have seen. In addition, if the type ID evaluates in a pointer preceded by the reference operator, as you have seen, this pointer has null value, type ID, and this pointer has a null value, type ID throws a bad type exception. Let's now look at what we call the type qualifiers. A type qualifier is used to define the declaration of a variable, a function, and parameters by specifying whether the value of an object can be changed. The value of an object must always be read from memory rather than from a register, and more than one pointer can access a modifier of memory address. C++ recognizes the following type qualifiers: the const, the volatile, the restrict, the align. Standard C++ refers to the type of qualifiers const and volatile as CV qualifiers. In both languages, the CV qualifiers are only meaningful in expressions that are L values. When the const and volatile keywords are used with pointers, the placement of the qualifiers is critical in determining whether it is the pointer itself that is to be qualified or the object to which the pointer points. For a pointer that you want to qualify as volatile or const, you must put the keyword between the pointer and identifier. For example, if you have the statement as follows: volatile x being declared as a pointer of type int, x is a volatile pointer to an integer. You can also have a statement as follows, where y is a constant pointer to the int variable z. For a pointer to a volatile or const data object, the type qualifier can be in any order, provided that the qualifier does not follow the pointer operator. For example, this declaration statement indicates that x is a pointer to the volatile integer, while in this statement, x is a pointer to volatile int. While in this other statement, y is a pointer to a constant int. Similarly, in this statement, y is a pointer to a constant int. Therefore, a statement like const int pointer1 defines a pointer to a constant integer. The value pointed to cannot be changed. In this other statement, which is a declaration statement that reads as integer, or we are declaring a pointer to, which is a constant pointer, and is a pointer of type integer, defines a constant pointer to an integer. The integer can be changed, but pointer to cannot point to anything else. Similarly, a statement like this one defines a constant pointer to a constant integer. In this case, we have a constant pointer called pointer2, which points to a constant integer, which is of type int. Neither the value being pointed to nor the pointer itself can be changed. You can put more than one qualifier on a declaration. The compiler ignores duplicate type qualifiers. A type qualifier cannot apply to a user-defined type, but only to objects created from a user-defined type. For example, if we have a structure called omega, struct omega with members such as limit of type int, code of type char, and an object called group, which is volatile group, then it simply means that when type qualifiers are applied to a structure, class or a union, or class variable, they can also apply to the members of the structure, class or a union. So in this case, we have a structure called omega with the two members, limit and the code. And the object to manipulate these members is called group, and that is volatile group. So we use the word volatile, rightfully, followed by the name of the object. And with that, my dear students and the rest of the learners, we have come to the end of part 19 of this series. You can continue to part 20 of the 95-part series of tutorials in this series, in which we are going to learn about explanation of objects and classes in OOP. Congratulations for learning part 19 of 95 on data types conversion in object-oriented programming. You can access the rest of the videos, or you can access videos for the other parts in object-oriented programming series, as well as other computer or ICT videos by clicking or tapping on MLSWAP ICT YouTube channel below this video. Remember to subscribe to this channel by tapping the subscribe button below this video in YouTube if it's not currently reading as subscribed. You can also click on join member to enjoy more offers from this channel. For any further correspondence, kindly write it to us through the email mlswap@gmail.com. Thank you very much for listening to me. Let's meet in part 20 of the series, and God bless.